Hello everyone, welcome to this activity where we will explore what we call a gradient of a linear graph. Okay, so there is this competition track that is not drawn to scale, and John is participating in a fell running, which is like a mountain running, where he has to overcome many different types of slopes in order to get to the finishing line. So this is the story, okay? This is the scenario. The competition has started, so I'm going to focus now on the starting line. The competition has started. He's going up a gentle slope. After traveling for a short distance, he came across a steep slope all the way. He ran up, and upon reaching the peak of the mountain, he finally reached flat ground, and after which he needs to run down the slope that is also steep. And after a while, he came across a gentle slope. Just when he thought that the race is going to be over, he came across the steepest slope he has ever seen. After the torture that he went through, he reached a gentle slope. And he could see the finishing line, but he still needs to run a certain distance on flat ground before he finally reach. So this is an illustration of a scenario that will help us to understand a bit about gradient. And so there are two questions that we would like to answer. How many different types of slope there are? So in this case here, I could see a gentle slope, and I could see a steep slope. So there are two types in general, okay? What is the difference when he runs up a slope and runs down a slope? Yeah, common sense. Running up is harder, okay? And now we can go right into today's lesson on gradient, which is a measure of steepness of a slope. Alright, now that we know that the gradient is a measure of the steepness of a slope, and that there are different slope means that there are different types of gradient. Okay, so there are basically these four types of gradient that we are interested in. So I'm going to zoom in one by one. So for the first time, alright, we are actually looking at a positive gradient, and there are some properties that we are interested in as the x, as we move along the x-axis from left to right, the y coordinate increases in value. So we say that this graph is actually increasing and sloping upwards. So the opposite of this would be a negative gradient, which is the opposite. So as we move from left to right again, the y coordinate actually decreases, and the graph is decreasing and is sloping downwards. Now as we move to the next gradient, which is horizontal line, where the y coordinate remains the same, gradient is actually 0. Okay, it's a measure of steepness. If there's no steepness, there's 0 gradient. Yeah, so if we move from left to right, the y remains the same. Okay, so this graph, if we can see very clearly, it is a horizontal line. And the last one is a vertical line. The last example, gradient, it does not exist. So at this point, we shall call it undefined. Okay, because this is because the gradient is of such a large number that at this point in time, we have yet to define that number yet. Okay, so you can see that as x move from left to right, the x coordinate in this case remains the same. Only the y changes in value. Okay, and we can see that it is actually a vertical line. And it is at this point in time I would like to introduce a formula on how do we calculate gradient. We can calculate gradient given any 2 points, and do take note that given 2 points, which I call them x1 and y1, x2 and y2, gradient is basically the vertical change in y. Y is at the top. And how do we calculate the vertical change in y? We just need to minus the 2 y coordinates, meaning y2 minus y1, or y1 minus y2. And we divide by the horizontal change, which is the change in x. So given the x coordinate, x2 minus x1, or x1 minus x2. Now, these two formula works. Okay? And now we shall now look at examples to illustrate how do we make use of this formula.